Okay, so this is question 8 for 2015 paper 1 section B. So let's get stuck in. It's a 50 marker. Now again, as I said previously, I'd suggest you pause this video and make a go at attempt part A and pause each different section. Just give it a go yourself. So the daily profit of an oil trader is given by the profit function P equals 96 times X minus 0.03 times X squared. So first thing I go, you could call that Y equals X, but just to call it P for profit. And X is the number of barrels of oil traded every day. Now, it says a square on the X, so I know it's quadratic. It's a negative X squared, so I know that it would look like that if I had to graph it. Okay. So, first, if you test this, if you put 500 into the function, you're going to get 40,500. So, rinse and repeat. So, 1,000 into the formula. We'll go to the answer in the next page. I've done a sample calculation here where I put 1,000 in instead of X. So put that to the calculator, you get 66,000. I can just backspace, delete the 1,000, put in 1,500, delete the 1,000, put in 1,500 and go again. Get like 76,500. Put in 2,000 instead of X, get like 72,000. And lastly, put in 2,500 instead of X in both places. And I get my 52,500. So that's part A. Move on. Now they're now asking me to graph it, okay, so I have loads of different points here. So I start off here at 500, where that meets with 40,500. So 40,500 is 4,100. It's roughly there, okay. And you just keep going, okay. So I'm going to go to the answer. It should look like this. Now I have other guidelines on here from different answers later on, okay, so I'll be referring back to this. But that's, you join all the points together now, not in straight jagged lines. Okay, I've got one continuous line going through it, and I do it in pencil. Okay, so if you have to remove it, you can. That's my graph. I'm saying use the graph now to estimate the daily profit. So the daily profit is the y-axis when the 1,750 barrels are traded. So that's the x-axis. So find the value on the x-axis. So that's 1750 here. Okay, bring it up to where it hits the curve, bring it across, and that's approximately my answer, which I'm going to read off as 76,000. Okay, I may have done something different in the notes, but we'll see what I said. It's uber accurate. Okay, probably around 76,000. Your answer here won't, if whatever answer you get, you can use it in the next part if needed. So you're within the tolerance there. Depending on how you read your graph. Now the next one then, okay, is the number of barrels traded when the daily profit is 60,000. Okay, so let's see what that means. And the daily profit again is on the y-axis. So go back here for 60,000. If I bring it across, it actually hits the curve at two places. Okay, so I drop it down and I drop it down. And I must explain that, okay, if you think the curve here, just producing more stuff doesn't necessarily mean more profit. There comes a point if you have to try pump more things, more amount, you may need a second rig, oil rig, a second shift, or those costs can add up and eat away at the profit. So there is a maximum point always where your profit is maximized. And companies want to be at that point. They are still making profit if they pump more, but they're not making maximum profit. And the companies, why sell off your resource for less profit than you potentially could make? So there's 2 points here for 60,000. If I drop it down, I can read off that figure as being, what's that? It's 750, so you're looking around 8, half 750, 850 maybe. Okay, and again here, dropping it down, you're reading off whatever the value works out to be. So there's a space of 5,000. And so each box here represents, between 2,500 represents 125. So that's 2,000, 125 and 125, so that's 2,750. That's about 3/4 of 125, which would be in and around 105. So I'm assuming the answer there is 2,750, 2,855, 2,856, or 2,60, 2,860. Let's see what I said here in the answer. 2,350, so 850 or 2,350. Does that make sense? 2,350. 2,3. That's 2,250. Okay, 2,250 kind of makes sense. Okay. So that's tricky because the boxes, if it's up by hundreds, it's much easier. But the fact it's going up by 125 makes it a little bit more awkward, a little bit more taut. But if you're anywhere in the tolerance, and even the correct labelling there of the diagram, with whatever value you think is most likely, it's going to get you the marks. Now, so that's part C, part 1 and 2 done. Okay, either both work marked as one question, and so if it's a 5C grade. Now, part D here says use calculus. So calculus is another word for differentiation. Okay, to find the number of barrels of oil traded that will earn the maximum profit. So you're looking for a max and mins here. Okay, now we've done them before in 2016. When I see anything to do with profit or, with a graph like that, I'm kind of expecting a max and min question. It may not always be that way, but that's the point of here. Look for that point, or if it's like a minimum, if it was a minus x squared, okay, or a positive x squared. So remember, it's a graph. A quadratic looks, if it's minus x squared, looks like a mountain. If it's positive x squared, looks like a valley. Okay. Let's go ahead and look at the answer. So what I've done here is I've taken my original equation that describes the profit based on the number of barrels produced. I want to find out the change in profit based on the number of barrels produced. So that's what differentiation does. Ultimately, I'm trying to find an equation to describe the slope at any point. So I'm differentiating p with respect to x, so you write the p dx to show that what follows has been differentiated. So if a mathematician wanted to reverse it, you can go back by a process called integration, which is not something on the past leaves our course. But integration is a very important process. But it leads on to the point that everything in maths must be reversible. So the opposite of addition is subtraction, the opposite of multiplication is division, squaring is square rooting, the opposite of differentiation is integration. Okay. Now anyway, so what I've done here is I've found an equation to describe the slope at any point. Now at the maximum point, the slope is 0. So if I go back to the graph here, okay, the slope may be positive 5, positive 4, positive 3, positive 2, positive 1, 0, negative 1, negative 2, negative 3, negative 4. So at the maximum point, the slope is 0, by definition. Okay. So I've done that here, and I've put 0, so dp dx is the slope. We know it's 0 at the maximum, so I put that equal to my differentiated equation. You'll notice here this is the equation of one unknown, just x. I can solve for that. I bring the minus 0.06 x across the equal, it changes to a positive. Then divide the 0.06 across, back across. So remember, it's 0.06 times x. When you bring it across the equal, because I want x on its own, it does the opposite on the far side, so it becomes divided. So it's 96 divided by 0.06 gives me this answer of 1600 barrels. Okay. Now I found the number of barrels. That's part 1 done. Now, always or usually with max and min questions, they're going to want to find the y value, now in this case the p value, and that will represent the maximum profit. So you use your original equation. This equation is describing profit relative to number of barrels. I now know the number of barrels, therefore I can calculate the profit at the maximum point. So I put the 1600 in instead of x in both parts, put through the calculator, and I got a maximum profit of 76,800, which I should be able to confirm in my graph. 70 is the maximum point roughly there, so 76,800. Yeah, it's definitely in the range of correctness. Okay, so I'm not raising any red flags. And that's part D, part 2. Okay, so again, I'm assuming you're pausing here all the way along. So we get started now in E. You're familiar with the question if you've read through it. The trader will not make a profit if he trades more than K barrels of oil in a day. Okay, calculate that value. So he makes 0 profit. Okay. So basically the hint here is you're given a quadratic equation, the p equals whatever. If there's no profit, that p value is 0. And that's the trick here. Okay. If I go ahead with the answer, so I've done that here. That's the two concepts, the p equation. That p is equal to 0. Put them together, so 0 equals that. And this is a quadratic. Okay, if I solve this quadratic, I'm going to find where this quadratic, the curve would cut the x-axis. Okay, now in the graph we drew, I can scroll back here. We don't actually show that, but that will be the point. I'm going to rough that should be one of my answers. And if that curve continues, it should be somewhere ballpark of that answer. Okay, if you produce, if they only produce, what's that, around 400 barrels, they don't make enough to make profit. If they produce too many, for whatever reason, the profit goes away. It costs too much to get it out of the ground or whatever. We'll find it. Now, by solving that quadratic, I could use the minus b formula. Okay, the a value would be minus 0.03, the b value would be 96, the c value would be 0. Or I can use a type of factorization, okay, where I remove one of the unknowns. I basically rewrite this in this form as two factors. If I multiply this again, I will go back to my previous step. So it is reversible, so therefore it's true. So I have two values. If x times something else is 0, one of them must be 0, or potentially both. So x can be 0, okay, or x can be, now I'm going to solve this little mini equation here. Bring the minus 0.03 across to equal, becomes positive. To cross divide the 0.03 into 96, and I get 3,200 barrels. So if I go back to my graph, does that make sense? 3,200. Okay. Business drawn there, maybe get 3,200 be over here. It's in the ballpark. And this one here, it tails off to 0. It's kind of unexpected. Okay, so yeah, 0 barrels, 0 profit. Okay, I don't really get that. Okay, I would have expected it to be somewhere around 400 barrels. But I know what we've done is right. This is first of the marking scheme. Okay, so that the 3,200 barrels is the x value. That will correspond then to the value of k. Okay, so I've said it there, just more information about what I'm talking about. Hopefully that makes more sense. Again, I go back at it again. If in essence, oftentimes in these kind of questions, it's about reading the question carefully, having previous experience and knowing when to do what. And this is one prime example of it can be very, very tricky until you realize that P is the profit, P is 0. Put 0 equal to your equation, solve the quadratic, job done. Now that's question 8 done, much nicer than question 7. So best of luck and thanks for listening.